Beneath your feet, under cities, oceans, continents, mountains, and the entire weight of the planet, there is a world no human has ever seen.
Not a cave, not a sea of lava, not a hollow chamber from science fiction. At the center of Earth is a glowing sphere of metal, a solid inner core surrounded by a molten outer core buried roughly 3,000 miles down. It is about 1,221 kilometers thick as a sphere, made mostly of iron and nickel, and as hot as the surface of the sun. And what makes this story even stranger is that Earth's inner core is not just sitting there like a frozen metal ball.
Recent seismic studies suggest it has changed its relative rotation over time, and the soft outermost part of it may even deform. Deep inside our planet, the center of Earth may be more dynamic than we ever imagined. Tonight, we're going all the way down.
The Earth looks stable, ancient, massive, unshakable. But that feeling is an illusion created by the thin outer skin we live on.
The crust beneath us is tiny compared with what lies below it. Under that is the mantle, about 2,900 kilometers thick. Beneath the mantle sits the liquid outer core, roughly 2,200 to 2,250 kilometers thick. And inside that, at the very center, is the solid inner core.
In other words, the deepest part of our planet is not rock at all, but metal. That hidden metal heart matters more than most people realize. Because without the deep core, Earth would not be Earth as we know it. The system of heat flow, motion, and electrically conducting liquid metal in the outer core generates most of our planet's magnetic field. That field helps shield Earth from the solar wind and shapes the magnetic environment that surrounds the planet. So when scientists study the inner core, they are not just asking what lies at the center of the world. They are asking how this planet stays alive, protected, and geologically active over immense spans of time. That is one of the most beautiful parts of this story. We did not discover the inner core by drilling. We did not discover it by seeing it. We discovered it by listening. When earthquakes strike, they send seismic waves through Earth in all directions. Some of those waves pass through rock, some bend, some reflect, some vanish from places they should have reached. And by carefully tracing those missing and returning signals, scientists learned that the planet's interior is layered. In 1936, Danish seismologist Inge Lehmann studied unusual earthquake signals and proposed that Earth's center was made of two parts, a liquid outer core and a solid inner core. She realized that some P waves which should have been deflected away were instead appearing where they should not. The best explanation was a hidden boundary deep inside the core where waves were reflecting or refracting from a solid center. Her idea was later confirmed by more sensitive seismographs. That remains one of the greatest detective stories in science. No one went there, no one touched it. A human mind saw patterns in shaking ground and revealed a metal world at the center of the Earth. At first, the inner core seems impossible. How can something so hot be solid? The answer is pressure.
The inner core is mostly iron and nickel, and temperatures there are estimated to be comparable to the sun's surface. Under ordinary conditions, metal that hot would be liquid.
But the pressure at Earth's center is so extreme that atoms are forced into a tightly packed solid structure. That is why the outer core is molten, while the deeper inner core remains solid.
Seismic evidence also supports that picture. S waves do not pass through the liquid outer core, but shear energy can be transmitted through the inner core, which is why scientists infer that the inner core is solid.
So imagine it, a solid sphere of metal, brighter than a furnace, buried deeper than imagination can comfortably hold, locked in place by gravity, crushed by the weight of an entire planet. It sounds unreal, but it is sitting there right now, beneath every ocean trench and every desert horizon, beneath every city light and every sleeping forest. In many ways, the inner core is like a planet inside our planet. It is not enormous compared with Earth as a whole, but it is still vast on a human scale.
NASA describes it as a solid sphere of iron and nickel about 1,221 kilometers thick, while other educational geophysics references describe the solid inner core region as about 1,250 kilometers thick. Either way, we are talking about a gigantic metallic world suspended within the molten outer core.
And it is not necessarily uniform. Seismologists have long found that the inner core has a complicated structure. Nature notes that it has a rich inner structure, and recent work continues to suggest that different regions of the inner core may transmit seismic waves differently. That means the center of Earth may contain internal textures, directional patterns, and structural complexity that we still do not fully understand. So even after nearly a century of study, the inner core remains less like a solved object and more like a frontier.
A hidden frontier, a buried frontier, a frontier no spacecraft can visit and no robot can descend to.
For years, one of the biggest debates in geophysics has been whether the inner core rotates at exactly the same rate as the rest of the planet, and the answer appears to be not always. A 2024 Nature study analyzed 143 pairs of repeating earthquakes, many from the South Sandwich Islands between 1991 and 2023, using waves that passed through the inner core and were recorded in northern North America.
The researchers found that some waveforms changed and later reverted, which let them track times when the inner core returned to a previous position relative to the mantle. Their conclusion was that the inner core gradually super-rotated from 2003 to 2008, then from 2008 to 2023 sub-rotated back along the same path 2 to 3 times more slowly. That does not mean Earth's core stopped spinning in any dramatic movie sense. It means the solid inner core appears to have changed its motion relative to the mantle and surface above it. In other words, Earth's center may drift slightly faster or slower than the outer layers over years and decades. Another Nature geoscience summary notes that seismic observations suggest the inner core's differential rotation changes over decades and may follow a multi-decadal oscillation with a period of about 7 decades, coinciding with variations in length of day and Earth's magnetic field. That does not prove simple cause and effect, but it strongly suggests that the major layers of Earth interact dynamically. So the center of Earth may not be a fixed anchor. It may be part of a deep, slow, planet-wide conversation. And then the story got weirder. In 2025, USC researchers reported evidence that the near surface of the inner core undergoes structural change. Their interpretation was that the shallow boundary region of the inner core may deform over time, meaning the outermost part of the solid core is not perfectly rigid.
Warm, Nature Geoscience summarized the same line of work by saying that more is changing than just the inner core's position, and that the soft outermost inner core probably deforms. Think about what that means.
The deepest solid object in our world may not only shift in rotation relative to the mantle, it may also flex or deform where it meets the turbulent liquid metal around it.
That boundary between inner and outer core may be one of the most alien environments on Earth. Solid iron under crushing pressure, in contact with swirling molten metal, responding to forces no human being will ever directly experience.
This is not the simple textbook picture many of us grew up with. This is a living, deep Earth system. Now, here is the question that makes this more than a geological curiosity. Why should anyone care what a metal sphere 3,000 miles beneath our feet is doing? Because the core is tied to the magnetic field that helps protect Earth. NASA explains that nearly all of Earth's geomagnetic field originates in the fluid outer core, where convective motion and Earth's rotation generate electrical currents. The magnetic field produced by that geodynamo extends far into space, where it interacts with the solar wind.
USGS likewise notes that Earth's core generates the main part of the magnetic field measured at the surface, and the inner core is part of that engine.
Nature's 2024 Inner Core paper states that the inner core influences the pattern of outer core convection and therefore Earth's magnetic field. NASA's educational description also notes that heat flow from the inner core helps drive the convection currents in the outer core that generate the field.
So when the inner core changes motion, or when its outermost layer deforms, scientists pay attention. Not because the sky is about to fall, not because compasses will fail tomorrow, but because every new clue helps explain how Earth's deepest engine actually works. And that engine is the reason our planet has remained magnetically protected for immense stretches of time.
What makes the inner core so captivating is not just what we know, it is what we still do not know.
We do not know every detail of its composition. We do not know exactly how its internal structure formed. We do not know how smooth or uneven its boundary really is.
We do not know precisely how its motion couples to the outer core, the mantle, the magnetic field, or tiny changes in the length of Earth's day. We are still building this picture from echoes, from wave paths, from repeated earthquakes.
From patterns in data so subtle they can be missed for years. That means one of the greatest unexplored realms in science is not a distant galaxy. It is the center of the planet you are standing on.
So the next time the ground feels still, remember this. Beneath the pavement, beneath the bedrock, beneath the tectonic plates and the convecting mantle, beneath an ocean of liquid iron, there is a blazing solid sphere turning in the dark.
A hidden metal heart, a world inside the world, a place discovered not by traveling there, but by learning how to listen. And even now, after decades of research, it is still changing, still moving, still guarding secrets. Earth is not a dead rock with a quiet center.
It is a layered, dynamic machine. And at the center of that machine is one of the strangest objects in the known world, the inner core of the Earth. If you enjoyed this journey into the hidden depths of our planet, subscribe to Infinite Science and stay with us for the next descent into the unknown.